Hi everyone, this is just a short video to talk a little bit about how we can help kids learn by connecting to what they already know. I'm going to use an example of indices just to illustrate the point. Whenever we try and introduce a new concept to students, what's important is we try and connect to what the students already know and then we build on from their current understandings. So this means when kids turn up to class, we don't treat them like they don't have any background knowledge at all or they've got no idea about what we're talking about, but we try and think about what they would already know and understand and use that as a foundation from what we're talking about. In simple terms, this would be called constructivism, and you may have heard of that as a theoretical name for this way of doing teaching. But in simple terms, if we try and connect to what they already know and then try and build on from there is a good way to start. So here's an example. When you come to introduce index laws, the students may have done it in year 10 or not, but what we do know is when kids turn up, they often will understand that 10 cubed is the same as 10 times 10 times 10, which is 1,000, and 10 squared is the same as 10 times 10, which is 100, and 10 to the power of 1 is 10. So what I try and do is show the students this so they can try and see the patterns. So at the moment, I'm just working with what they already know. But then I try and see if they can see any sort of pattern. And you'll notice in the middle column there that you may notice is just a decreasing multiplication of 10. So then we try and guess what might happen in the next one. If you look at the last column, it's divided by 10 each time, so the next one would naturally be 1. And then another way of connecting it might be through to help them understand index laws. So for example, if we want them to learn about index laws for multiplication, go back to what they already understand, which is 10 cubed is 1,000 and 10 squared is 100. So what's 100 times 1,000? Well, it's 100,000. And if you count the zeros, it's easy for the kids to see that that's 10 to the power of 5. Now once they get that, I then try and take them back to look for the pattern between the original question, which is 10 cubed times 10 squared, to this answer, which is 10 to the power of 5. The reason I use 10 is it's easy for them to see the patterns. Similarly, I might try and introduce the law about division of indices. 10 to the power of 5 divided by 10 to the power of 2, you can see a similar sort of process, and then at the end try and say, can you see any pattern between the question and the answer? Now obviously I'd give them more than one, I'd give them a few, but the idea is to try and start with what they already know and understand, and see if you can use that to bridge to the new things you want them to learn, and particularly the things they can see and understand. That way they're building up the new knowledge for themselves rather than you just giving them a list of index laws which they copy into their book and memorise. Fundamentally, when using this approach, I've found that the kids learn it reasonably quickly, in fact just as quickly as if I'd just written the laws on the board and they'd copied them down. But more importantly, they seem to remember and understand it. Similarly here, I've just put another one there at the bottom, just trying to show why 10 to the power of 0 would be 1. And you'd try it with other numbers too. I'd probably go to 2 powers of 2 after this to try and show the same thing. So if we start with what they already know, we build the new ideas, and then we generalise or look for patterns that we can generalise into these what we call the index laws. And that way the kids will still have the same laws we would have taught them anyway, but they would have it with more of a foundation of what they actually mean and a conceptual understanding rather than just an instrumental understanding of what the laws are. So give it a crack, see how it goes. Thanks.